For decades, software engineering functioned as a professional apprenticeship. While theory was learned in a classroom, the actual mechanics of building and maintaining systems were mastered on the job. The currency of that apprenticeship was grunt work. Junior developers were handed the tedious tasks, writing boilerplate syntax, patching minor bugs, and building routine features. That repetition was by design. It forced new coders to read existing codebases, trace errors, and slowly understand how massive, complex systems function under the hood. Today, developers are adopting what researcher Andrei Karpathy calls vibe coding. Instead of typing out line after line of logic, a user writes a high-level prompt in plain English. AI assistants then instantly generate, compile, and debug the underlying structural syntax. By automating these routine syntax-level tasks, generative AI is effectively removing the introductory work that has historically served as the first step into the profession. For corporate operations, this looks like an immediate win. Non-technical managers can now spin up short-lived, disposable applications for targeted tasks without hiring an entry-level engineer to write the code. This chart tracks software employment trends over time. After steady growth, we see a sharp 20% drop in 2022 for entry-level positions. A Harvard study splits this data following AI adoption. Junior hiring falls another 10% over 6 quarters, while senior demand stays perfectly flat. Organizations are securing immediate operational savings by cutting junior roles, but in doing so, they are creating a lost cohort of software engineers. They are trading the long-term human talent pipeline for a short-term reduction in payroll. When AI tools write code quickly, managers assume the engineering team is becoming highly productive. However, a GitClear study analyzing over 211 million lines of code shows a different reality. AI models strongly prefer suggesting entirely new blocks of text rather than carefully modifying or refactoring existing architecture. This visualization represents how a codebase degrades over time. Over a 4-year period, the share of copy and pasted code grew by 48%. Because the code being pushed is brittle and heavily duplicated, the role of the senior developer is shifting. Instead of designing new features, they spend their days acting as AI overseers, trying to untangle and patch machine-generated spaghetti code. The sheer volume of flawed, rapidly generated code entering production environments is actively overwhelming the exact senior architects required to keep those systems online. To safely review and correct AI-generated code, a developer needs elite debugging skills. Yet relying on an AI to write your code prevents you from practicing those exact skills. Researchers at Anthropic tested this dynamic using a randomized controlled trial. They took 52 software engineers and asked them to build applications using an unfamiliar Python library, splitting them into a manual group and an AI-assisted group. This chart compares the results of a follow-up comprehension test given to both groups. The developers who coded manually retained the information, while the AI-assisted group scored 17% lower on understanding the system they had just built. The performance gap becomes a critical vulnerability when the test is isolated to debugging tasks. The AI-reliant group severely lacked the ability to read foreign code and locate errors, which is the primary skill needed to evaluate AI outputs. This happens because of a behavior pattern called AI delegation. When a junior developer blindly accepts a block of generated code, they bypass the cognitive struggle of writing it themselves. That friction is required to commit complex logic to memory. By making coding effortless, these tools remove the cognitive struggle that anchors new information. Without that struggle, developers fail to build the foundational mental models required to understand complex software architecture. We are now looking at a 10-year horizon, where the volume of code produced globally will multiply by an order of magnitude. Systemic complexity is compounding as organizations weave together legacy architectures, new visual platforms, and hundreds of AI-powered microservices. As these systems grow in size and fragility, building them without enough qualified human engineers pushes the entire structure to a breaking point. The tech industry is sleepwalking toward an architectural crisis. It is rapidly expanding its digital infrastructure while simultaneously starving the pipeline of the minds required to sustain it. Engineering leaders can prevent this by completely rethinking how they measure productivity. Metrics like lines of code added or pull request volume only reward developers for dumping raw AI text into the repository. Instead, organizations must heavily curate how their newest employees interact with these tools. That means setting policies that strictly prohibit junior engineers from completely delegating their tasks to a model. When new hires are onboarding or transitioning to unfamiliar frameworks, they should be required to run their AI assistants exclusively in explanatory or interactive learning modes. In this setup, the AI acts as a conceptual learning partner. The developer must ask clarifying questions and code independently, which restores the cognitive friction needed to build a strong foundation in reading and debugging code. To survive the automated era, companies must stop treating junior developers as a disposable expense. By actively engineering a modern apprenticeship, they can secure the expert human oversight required to keep the future of software online.